Hi everyone, this will be a video on priority queue for my X281 IA application. So I found this problem about k largest element on LeetCode, okay, and I found it interesting and thought it could be solved using priority queue, particularly mean PQ. So the problem is very simple. You are given a stream and then you're gonna find the k largest element in the stream, okay? So this object k largest will be constructed using this where instantiate using this syntax over here. Actually, no, just just look at this. You are passing a vector of numbers of integers I mean, and like the k that you want to use for the k largest element. Okay, it's very simple, and you are also given this constraint, not really important. Okay, the last one, it is guaranteed that there will be at least k element in the array when you search for the k element. So you don't really have to worry about the mean PQ, the size of mean PQ being less than k, or like there'll be less than k element in your vector or whatever container that you have. Okay, let's see how we can use mean PQ to solve this. Let's do some drawing. So the idea is to have a mean PQ. Okay, let's say we have a mean PQ of size k. Oops. Of size k. Okay. By mean PQ, we know that the top of this PQ will have the smallest element of in the queue, right? And we'll select some values from the stream to put in this PQ and make sure that we go through all the elements in the stream to make this mean PQ what we want. Okay, so at the end of like going through the stream, we should be expecting this mean PQ to have the largest element in the stream at the back of this PQ, right? So this should be the largest element over here, and it follows that this will be the second largest, and so on and so forth. Because this is of size k, this will be the k largest element, which is what we want, right? So at the end, we just need to return the top of this mean PQ. So the hard part of this problem is how do we select which value to put into this mean PQ? Okay, so it can be split into like two stages. Stage one, and this is for both k the constructor and also for the add function. Okay, it will be very similar. Okay, so stage one is when the size of mean PQ, okay, mean PQ dot size is less than k. Then you just push blindly, just push whatever value that you are reading in, whether from the vector or from the stream. And once the size of mean PQ reach k, and this is the second stage, which is the mean PQ dot size is equals to k, you have to check if the new value, okay, if the new value is greater than the top, which means it is greater than the smallest element on the mean PQ, what do you have to do? You should push this new value and you should pop the smallest value on the mean PQ. And actually, this order doesn't really matter. Okay, this order doesn't matter because even after you push, the smallest element will still be on the top of the queue. And if you pop first, after you push, the size of this mean PQ is still k. Okay, so let's see how we can implement this. First of all, I think we would need to first, let me put them side by side, and we don't need this. Let me construct the mean PQ that we want using, I just like to put std everywhere. Priority queue of int, underlying structure is vector of int. And then because we want to construct a mean PQ, we should use the std greater int comparator Oh, I forgot std for this, but I think it doesn't really matter. Just a habit to make it there. And let's call it mean PQ. Mean PQ. Okay. And we also want to keep track of the k because we are only passing in here, but we don't really have a variable, a class member function, member variable to store it. So I'm just gonna let like int k. Okay. So remember to initialize it using initializer list. So k will be from k int. Okay. So now we have our k. And now we just have to because like for the constructor, we are given a vector. We just need to look through this constructor and then read in the values and then push the value into min PQ if either the min PQ size is still less than k or if it satisfies the condition that the condition that we have over here. Okay, let's turn it into code. The easiest way to look through a vector is I'm just gonna write a traditional for loop. You could use a range based for loop for int I equals 0, I less than nums dot size, I plus plus, and then check the condition. Stage 1 will be if min pq dot size is less than k, then just push blindly. Push nums of I, then else. We don't even have to check if the size of PQ is greater than K because we know that by pushing and popping at the same time, we will guarantee the size of min PQ to be remain as K. Okay, so we need to check this condition. If the new value, which is nums of I, is greater than min PQ dot pop, then what should we do? We should push the new value, the min PQ dot push of this nums I and pop. Okay, min PQ dot pop. And like I said, this order may be changed. Okay, these two, it doesn't really matter. Okay, and yeah, this will be for our constructor. We don't have to return anything from here. So the add function is where we need to return the k largest element. So let me just write it here in case I forget. Return, it will be from our min PQ dot top, right? Okay. So when we are adding a new value to this from the stream, it will be very similar. Okay. And of course, because the problem says, okay, where are the specs? Because the specs say it will only be guaranteed there will be k element in the array when we search for the k element. So there will be a situation where there are k minus 1 element being passed into this object and we add the k element. So basically everything from the stream, from the vector and from the stream will be on the priority queue. So we still have to take care of the first stage, which is where the min PQ size is less than k. Okay. So if min PQ dot size is less than k, what do? I forgot where is this? This should be min PQ dot push. Okay. Then min PQ dot push this new value. And else we'll check the condition. If the new value is greater than the smallest integer on our min PQ, then we will, let's do pop first this time, okay? Because it really doesn't matter. Yeah, min PQ dot pop, and then min PQ dot push this new value, okay? And then return min PQ dot pop. Else. Hey, yeah, so we should be good. Let's see. Yes. So this is how you use min PQ to return the k largest element in a stream. Thank you.